Okay, this is our second last section for this semester, and in this section we'll be solving exponential equation and a log equation. Okay, now so the very first method, so let's try to solve the exponential equation at first, and after that we will solve logarithmic equation. When we are solving the exponential equation, the very first step or the very first method is that we try to make a same base on a both side. Okay, if you have an exponential equation, okay, so we try to make the same base on a both side. Okay, for example, here we have a to the power x, this is the exponential form, and we have a to the power y. And both of these exponential expression have the same base, right? And if you have a same base on a both side, then you can write their exponents equals to each other. Okay, we have a to the power x equals to a to the power y. We have the base is same. If this is the case, then x is always equals to y. So every time if you see an exponential equation, always try to make a same base on a both side, and you write down the exponent equals to each other and you solve the equation. That's the very first step that you're gonna try. Okay, now let's do an example. So we have 2 to the power t equals to 128. On the left side, what is the base here? On the left side, 2. On the right side, what is the base? 128 is the base, right? Now our target is making a same base on a both side. Okay, we have a base 2 on our left side, we have a 128 on our right side. Now, is there any way we could write 128 in terms of 2? So that's what we're gonna look. Okay, we can't make a 128 base on a left side, but we might be able to make a base 2 on a right side. Okay, so we have 128, and how can we rewrite 128 with a base 2? 2 to the power 7. Okay, so we have 2 to the power t equals to 2 to the power 7. That's the very first step. Every time if you have an exponential equation, always try to make a same base. Now we have a same base, 2 on the left, 2 on the right, and if this is the case, then our exponent has to be equals to each other. So this exponent t from the left side, this exponent 7 on the right side, these two are equals to each other. It means our t is 7. So solving equation means we are finding the value of variable, right? Our variable is t, and we found our variable t is 7, and this is our final answer. Okay, so always we try to make a same base on a both side. Okay, before we go to the next one, let me add example, one more example here. Okay, this is not the one. Okay, so let's do one more example. Okay, we have 7 power 2x equals to 49. Okay, we have this exponential equation. On the left side, our base is 7. On the right side, our base is 49. So we try to make a same base on a both side. Now, how can we rewrite 49 in terms of 7? 7 is square. Okay, now we have a 7 base on the left side, 7 base on the right side. So we can write exponent equals to each other. So we have 2x equals to 2. 2x equals to 2. So this is a linear equation. How do we solve this? We divide both sides by 2. And so 2x divided by 2 is x equals to 2 divided by 2 is 1. And this is the solution. Okay, we always try to make a same base on a both side. Now, the second case is that what if we can't make a same base on a both side? Okay, for example, our next example. So here, do you have any question in these two example? You have exponential equation, you make same base on both side, you write down the exponent equals to each other, you get the solution. Now here, we have a 10 to the power 2x minus 1 equals to 3 to the power x. Now, is there any way we could make a same base on both side? We can't, right? The base on the left side is 10 and the base on the right side is 3, and there is no way we could make a same base on both sides. Now, if this is the case, what we're gonna do here is that we're gonna take a log on or we're gonna apply log on both sides. Okay, so we can take a common log or a natural log. Okay, so we take the log on a both side. Okay, now here taking log means you write down log in front of each exponential form. So you have a log of 10 to the power 2x minus 1 equals to log 3 to the power x. So you're gonna apply, you can take log to a base 10, or you can take natural log ln, or you can take any log, but make sure you must have a same base. Okay, so in general we take a common log. Okay, and you can use the calculator to find the common log value. So you can always apply common log or natural log. Now let's simplify this. So solving means we are finding the value of x. Okay, now on the left side, so what do we have? We have a log of exponent, right? Now what can we do to this exponent? We can write in front, right? So we can write this exponent in front of log. So this is 2x minus 1. We have a more than one terms, so we're going to have inside parentheses times log of 10. Log of 10 is just a number. Okay, if you use your calculator you can find what is log of 10. It's just a number. Okay, equals to, similar way we have a log of 3 to the power x. So this is the exponent, so we can write this exponent in front of log 3. So we have x times log of 3. Okay, now we are solving for x. We have a x terms on the left side, we have x term on the right side. So we have 2x minus 1 here. Let's distribute log of 10. Okay, we have the parentheses and we have a product here. So we distribute log 10 for 2x and we distribute for negative 1. Okay, so 2x times log 10 is 2 log 10 and our variable x. Okay, negative 1 times log 10 is negative log of 10 equals to x times log 3. Now how do we solve here? How do we solve for x? So solving for x means we are making x alone by itself. So let's collect the term having x in one side. Okay, so we have two terms. So this is the one with a x and this is the expression with x. So let's collect these two terms in one side and the remaining on the other side. So let's subtract x log of 3 on a both side and let's add log of 10, and we know, okay, we know what is log of 10, right? What is log of 10? 1, right? So you can replace log of 10 by 1. So you are adding log of 10 on a both side. So these two cancel here, this cancel here. So we have a 2 log of 10 x minus x log of 3 equals to log of 10, and which is 1. So let me replace this by 1. So this is 1, so equals to 1. So we collected the terms having x in one side and the term without x in the other side. Okay, now in these two terms, do we find x as a common factor? Okay, so let's factor out x. So if we factor out x, we have a 2 log of 10 minus log of 3 equals to 1. So we factor out x because x is the common factor. Now how can we make x alone here? Now let's see, our x has this number. How do we get rid of this number from x? Divide by the same number, right? We have a product here. So we divide both sides. So we divide both sides by 2 log of 10 minus log of 3. So 2 log of 10 minus log of 3. Okay, so we can cancel this expression and this expression, which is just a number. So we have x equals to 1 over 2 log of 10. Oh, we know what is this log of 10. So let me 1, right? So let me replace this by 1, and 2 times 1 is just 2. So we have 2 minus log of 3. Okay, if you want to write your answer in decimal you can, or if not, this is your final answer. Okay, So this log of 10, log of 3, this is just a number, okay? Do not get confused here. If you wanna change here, if you wanna write down what is log of 10, you can use. Like you can replace log of 3 by use your calculator, enter log and enter 3, you get some decimal number and you can use that decimal, okay? But you are not required to do that. You can just leave it in terms of log. Okay, let's practice one more here. So here, let me add an example. So the next example, we're gonna have 3 times e to the power 2t plus 6 equals to 24. So this is the exponential equation. Now we are solving for t variable, right? We don't know what is t, so we need to find t here. Now here, so we have 3 times e to the power 2t plus 6 equals to 24. Now what would be your first step in solving this equation? So do we have like terms here? 6 and 24 are like terms, right? So let's collect these like terms together. So it means you subtract 6 on both sides. So we have 3 times e to the power 2t equals to this 0. 24 minus 6, that is 18. Okay. Now we have 3 in front of e to the power t. So let's divide both sides by 3. So we have e to the power 2t equals to 6. Okay. Now, is there any way we could make a same base on both sides? So on the left side, our base is e. E is 2.718. On the right side, we have base is 6. Now, can we make a same base on both sides? No. So if that is the case, we take log on both sides. Okay. Now here, in this specific example, our base is e. So let's take natural log. Okay. But you can still take common log. Okay. There is nothing wrong if you take common log. Okay. Now since our base is e here, so we're gonna apply common log ln on both sides. And if you take common log, still is correct. Ln of e to the power 2t equals to ln of 6. And you can take common log. Okay, it's not that you have to take natural log. You can take common log. Okay. Now we have ln of e to the power 2t. So this is the exponent. So we write this in front of ln. So we have 2t ln of e equals to ln of 6. Now what do we know about this ln of e? This is 1, right? And this is the reason why we use natural log. Okay. So we have 2t times 1, 2t equals to ln of 6. Now we need to get rid of 2. So we divide both sides by 2. And we know our t is ln of 6 divided by 2. And this is our final answer. Do not divide 6 by 2, okay? So ln of 6 is just one number. So you are not writing ln of 6 divided by 2 as ln of 3. That's not correct, okay? If you use your calculator and if you divide ln of 6 by 2, you get one decimal number, okay? And you can just leave this as your final answer. Any question? Okay, let's practice one more, then we'll start next logarithmic equation. Okay, so here, has anyone marked the homework for this section, 4.5? Anyone else? No? Okay. I'm sorry?
I have them marked like on a paper, on separate paper.
Do you have now? Oh, okay. Can you just give me one? Can you just pick one number from 5 to 36?
It's 9.
9. That's the easiest one.
Oh, okay. 17.
Okay. Let's just 17. Okay. And what is the next number you have for your homework?
After 17?
Yes.
19.
19. Then after?
21.
21. Okay. Next.
25.
25. Okay, next
27,
27, next
31,
31, next.
43,
Okay, that's different. Okay, now 17 is pretty similar to the one that we did, so let me choose one. So let me do 27. Okay, 17 is similar to our this example, similar to our example 1. Okay, so let me do 27. So here e to the power 2x, e to the power 2x minus 5 e to the power x plus 6 equals to 0, plus 6 equals to 0. So this is our exponential equation, and we need to solve this equation. Okay, now, so what would be our very first step here? So we take, so our 6 is not exponential expression, so let's subtract 6 on both sides. Okay, so let's subtract 6 on both sides. So this is 0. So we have e to the power 2x minus 5 e to the power x equals to negative 6. Okay, the next step would be, I'm sorry? Okay, applying log, does that gonna help us? Like if we apply, okay, for example, if we apply log on both side, so if we apply log on so we have a log of negative 6, right, which is undefined. So we can't find log of negative 6. So this is not gonna this is not helping here at this step. Okay, so we might need to apply log, but here if we apply log, it's not helping us. So is there any other way? Or, okay, let's not subtract 6 here. Now let's make a substitution. So let's substitute a for e to the power x. Okay. Now if this is the case, we have e to the power 2x, right? So can I write e to the power 2x as a e to the power x and a square? Is it same thing? So we have e to the power 2x, and this is same as e to the power x square, right? Minus 5 e to the power x plus 6 equals to 0. Now what do we know about e to the power x? This is a. So let's replace by a. So we have a square minus 5. Our e to the power x is a. 5a plus 6 equals to 0. So we had exponential equation. Now what kind of equation do we have here? This is a quadratic equation. We use a factorization method. So we use FOIL because the coefficient of square is 1. First term is a. Now can we find a two number whose product is positive 6 and sum is negative 5? Negative 3 and positive 2. Sorry, negative 2, right? Negative 3, negative 2 equals to 0. Now we have a two factor. We set each factor equals to 0. So we have a minus 3 equals to 0. A minus 2 equals to 0. Now here we have the linear equation. So we add 3 for the first equation. We add 2 for the second equation. So our a is 3. Our a is 2. But in this equation, are we solving for a? No, right? We are solving for x. Our x is a variable. So our x is a variable. So we are solving for our x. But our a is e to the power x. Now let's substitute our a as a e to the power x. So we have e to the power x equals to 3. E to the power x equals to 2. Now, what would be next step here? Can we make a same base on both sides? So we have a base e on the left side and 3 on the right side. We can't make a same base, so we apply log now. Okay. And what would be the best option to apply? Common log or a natural log? Natural log, right? So we have a base e here. So let's apply natural log ln on both sides. So ln on the left side, ln on the right side. So for the same thing for the next equation, ln on the left side and ln on the right side. Okay. So we have this exponent x, so it comes in front here. Similarly, this x comes in front of ln. So we have x times ln of e equals to ln of 3. So we have x times ln of e equals to ln of 2. We know ln of e is 1, right? Ln of e is 1. So x times 1 is x equals to ln of 3. X times 1 is x equals to ln of 2. So these two are the solution for this equation. Okay, next you have 31. So let's do number 31. Let me know if you have a question here. Okay, so in number 31, so we have x square 3 to the power x minus 3 to the power x equals to 0. And it does give us hint. And our hint is factor out 3 to the power x. Factor out 3 to the power x. So this is the hint given to us. So we have x squared 3 to the power x minus 3 to the power x equals to 0. So the hint is factor out 3 to the power x because we have 3 to the power x as a common. So let's factor out. So we have 3 to the power x as a common factor. We have x squared left minus. So if we factor out 3 to the power x from 3 to the power x, what do we have? 1, right? Equals to 0. Now, how do we solve this equation? So we have this first factor, this is the second factor equals to 0. So we have this is one number times the other number. So if we have a product of two number equals to 0, then one of this number has to be 0, right? So we set each factor equals to 0. So we set 3 to the power x equals to 0, and we set x squared minus 1 equals to 0. If you have a product of two number equals to 0, then at least one number has to be 0. Now the first equation, what kind of equation is this? What kind of equation is this? What do we call this equation? Exponential equation, right? Now the very first method is we try to make a same base on a both side. Is there any way we could make a same base on a both side? No, right? So if that is not possible, we apply log on a both sides. So let's apply log on a both side. And you can choose here natural log or a common log. Log of 3 to the power x equals to log of 0. So we have this exponent x, so it comes in front. So we have x times log of 3 equals to, now do we know what is log of 0? Now, is it defined? What is the domain for our log function? It has to be greater than 0, right? It means this number is undefined. If it is undefined, can we solve this equation? No, it means no solution. So from this equation, we don't have solution. Okay? Because we don't know what is log of 0, that is undefined. So we can't solve this equation. Now for the second equation, this is our quadratic equation, right? And we can solve this quadratic equation. We add 1 on both sides. So we have x squared equals to 1. And we need to get rid of a square. And when we get rid of a square, we get plus or minus square root of whatever we have on the right side. That is 1. So this is plus or minus 1. So our x is positive 1 or negative 1. Good. So two method. Whenever you see a exponential equation, always try to make a same base. If you have a same base, then you can just write the exponent equals to each other. Okay. Second method is, if you can't make a same base on a both side, you apply log on a both side. You can take a common log or natural log. It doesn't matter. Okay. So these are the two methods to solve our exponential equation. Now, okay, now here we have the next example, number 2. Suppose a bank pays an interest rate of 5%. So what is 5% here? How do we represent this interest rate? R, right? So our R is 5%. And how do we want our R? It has to be in always decimal. So we divide by 100 and we get 0.05. So this is our interest rate. Compounded continuously. Now, we did compound interest, okay. We had a two formula, okay. The one is, so amount equals to P time 1, like is it plus or minus? Okay, let me, is it plus? Plus R over N to the power N time T, right? And then next we have A equals to P times E to the power, is it RT? Now, at what condition do we use this one? When interest is compounded continuously. Okay, if your interest is compounded annually or semi-annually, okay, if you know N, then you're gonna use this formula, okay, but we don't know N. If there is a keyword continuously, you're gonna always use this expression, okay. So we're gonna use we're gonna have the continuously, so we're gonna use this formula. Okay, on an initial deposit of $1,000. Now, what is this initial deposit $1,000 for us? P, right? So P is the principal, and it can be a investment, can be a deposit, or it can be a loan. Okay, so this is our P. How long does it take? Okay, how long does it take means what are we looking? T, right? How long means a T. So we don't know what is T. So T is unknown. That's what we are trying to find. For an investment of $1,000, this is our P, to grow to a total of $1,200. Now, what is this $1,200? A, right? That's the amount that we get after T. We don't know what is that T. So our A is $1,200. Okay. Assuming that no withdrawals or additional deposits are made, round your answer to the 2 decimal place. Okay, now we know what we're going to use. So we're going to use this exponential equation. So we have A equals to P times E to the power RT. Our A is 1200 equals to P is 1000 times E to the power R. Our R is 0.05. T, we don't know what is this. So we need to find our T. Okay, now what would be our first step? Now before you apply log here, you need to get rid of 1000 from right side, okay? And how do we get rid of 1000? We divide both sides by 1000. This is 1. So 1200 divided by 1000, that is 1.2 equals to E to the power 0.05 T. Now we have base E on the right side and base 1.2 on the left side. We can't make a same base, so we apply natural log on a both side. So you're gonna apply ln on a both side. So we have ln of 1.2 equals to, this is the exponent, right? So it you can write this in front of log. So we have 0.05 T ln of E. And what do we know about ln of E? This is 1, right? Okay. Now we have ln of 1.2 equals to 0.05 T times 1 is 0.05 T. Now we are solving for T. So we divide both sides by 0.05. So this is 1. So we have ln of 1.2 divided by 0.05 equals to T. Now you're going to use calculator here. So can anyone help me here? So you make sure you are using ln, okay, not common log. So ln of 1.2 divided by 0.05. We get, is it like 3.6? Okay, so it tells us to round into 2 decimals, so 3.65 years. So after depositing for 3.65 years, you will get $1,200 if you deposit $1,000. So if this is the case, will you deposit your $1,000? You deposit $1,000 and after like almost like 4 years, you get $1,200. Is it worth it? You won't? Is the interest too low for you? 5%? But okay, the bank, they doesn't even give us the 5%, right? Maybe like less than 2%. So 5% is a good interest rate, okay? But if you choose to deposit like more, like if it was like $10,000, you might get a more interest, okay? But 5% is pretty good interest rate. Okay. Let me know if you have a question here. So you will be given these formulas, okay? You don't need to memorize this, but you should know which one to use, okay? And you should know what P is, R, T, and A from the this kind of real life problems. Okay, this is about our exponential equation. Now the next equation is logarithmic equation, okay? So we have the 4 step here. The very first step is isolate the logarithmic expression on one side of the equation. It means we are writing every log expression in one side and the constant or other expression in the other side, okay? In number 2, exponent both sides with respect to suitable base. Okay, now, okay, let's go to the example and just we'll see these steps here. So we have this example here. Now, in this example, which one is the log expression? So log of x to the base 3, this is the log expression, right? So we write down this expression in one side and the remaining on the other side. That's the first step. Always collect your log expression, every log expression in one side. So we need to get rid of positive 4, and for that we subtract 4 on both sides. So this is 0. We have log of x to a base 3 equals to 2. So collect your log expression in one side. Now, once you have the log in one side, okay, you need to now here we have the log in one side. Now we need to get rid of log. And how do we get rid of log? We rewrite in an exponential form. Okay, so once you have the log expression in one side, make sure you only have one log expression. Okay, sometimes you might have more than one log expression. Okay, and we know how to write the log in one expression. That's what we did yesterday. So here we already have one log. So in order to get rid of this log, we rewrite this expression in an exponential form. And where do we start from? We start from this x. So whatever the log has. So we start from x. So we have x equals to base. So base is our 3. So base is 3. And whatever you have on the other side, which is 2, it goes on the exponent. So we have x equals to 3 square, which is 9. And this is the solution. Collect your log expression in one side, okay, and make sure you write the log expression using one single log, okay, and after that you are getting rid of log. It means you are rewriting that in terms of exponential form and then you simplify. Okay, let's go to the next example. Now here, how many log expression we have? Ln of x, right? We have ln of x minus 1. So we have 2 log expression. Now let's collect every log expression in one side. Okay, for that we subtract ln of x minus 1 on both sides. Ln of x minus 1. So you are collecting every log expression, okay, in one side equals to 2. That's the very first step. Collect every log expression in one side. Now on the left side we have a log expression. Now how many log expression do we have? We have a 2, right? Now we need to write this 2 log expression using a single log. Okay, so we have a 2 log expression. This is the one, this is the another, and we need to write using a single log. Now here we have difference of 2 log, right? And if we have a difference of 2 log, what is that equals to? Log of quotient, right? So if you have a difference of log, then this is log of quotient. This is log of quotient. This is your numerator x and this is your denominator x minus 1 equals to 2. So you are writing in a single log expression. Now we get rid of log. Okay, so getting rid of log means we are rewriting this equation in an exponential form. Okay, so you're gonna start from whatever you have with along with log. So this is what we have. Okay, so we have this expression. So you start from here. So we have x over x minus 1 equals to, okay, you just write in whatever you have with log, equals to base. What is our base here? This is our natural log and the base is e. Okay, and whatever you have on the other side, we have 2. These 2 will be the exponent, e square. Now we have this equation, and what kind of equation is this? It's a rational equation. Okay, it is not exponential equation. Okay, the e is a number. E is just a 2.718, and you can just write down what is this. Use your calculator. You can write e square. Can you just help me? What is this e square equals to? So is a 2.718 squared. Or if you want to leave as a e square, you can. Okay. 7.34. Okay, 7.34. Okay, so we have this rational equation. Let me write one more time. So we have x over x minus 1 equals to 7.34. And how do we solve rational equation? To solve rational equation, the very first step is getting rid of denominator. So our denominator is x minus 1. And how do we get rid of this denominator? We multiply both sides by using the same denominator. So we multiply both sides by x minus 1. X minus 1. So you can cancel this. So we have x in the left side and we distribute 7.34. Okay.
It's actually 7.39.
7.39. Okay. So let me go with 7.39. Now you distribute 7.39. So 7.39 times x, 7.39x, 7.39 times negative 7.39. So this is a linear equation, right? And we know how to solve linear equation. So we subtract, we collect x term together. So it's minus 7.39x, 7.39x. This is 0. So we have x minus 7.39x, and that is equals to negative 6.39x equals to negative 7.39. You divide both sides by negative 6.39, negative 6.39, and this is 1. So x equals to, so negative negative cancel. So what is 7.39 divided by 6.39? 1 point. Okay. Good. Okay, let's practice another example. So we have log of 2x plus log of x plus 4 log of x plus 4 equals to 1. What type of equation is this? Log equation, right? Now, first step, we are collecting every log expression in one side. We already have that, right? So we can skip that step. Second step, we are writing every log expression using a single log. Okay, we have a 2 log here. We have a log of 2x and log of x plus 4. So let's rewrite these using a single log. And what do we have? We have a sum of log. And if we have a sum of log, what is that equals to? Log of product. So we have log of product. So product of this number and this number. 2x times x plus 4 equals to 1. Okay. Now, once you have the single log expression, you get rid of log. Okay. So getting rid of log means you are writing in terms of exponential form. So you are starting from here, so you write down whatever you have with log. So we have 2x times x plus 4 equals to base. What is the base here? This is a common log, so base is 10, and whatever you have on the other side, this is the exponent, so 1 is the exponent. Now we distribute here 2x for each x and 4, so 2x times x, 2x square, 2x times 4, that is 8x, equals to 10 to the power 1 is 10. This is our quadratic equation, right? So we have the quadratic equation. Okay, and we can just, 2 is the common factor, so you can divide every term by 2, okay? 2 is the common factor, so you can divide every term by 2. So we have x squared plus 4x equals to 5. You can use quadratic formula or you can use factorization. Let me go with factorization, okay? That might be easy for us. So let's subtract 5 on both sides. This is 0. So we have x squared plus 4x minus 5 equals to 0. Let's factorize using FOIL method. So x is the first term. Now let's find the two number whose product is -5 and sum is 4. That is -5 plus 1. So we set each factor equals to 0. So x minus 5 equals to 0, x plus 1 equals to 0. Oh, yeah, thank you. Yeah. So we have a positive 4. It means we're going to have a positive 5 and -1. So positive 5, -1. So our x is -5 from this equation, x is positive 1 from this second equation, and these two are the solution. Let me know any question. Okay, now let's go back here. Example number 3. Okay, the cumulative box office revenue from the classic children's movie Finding Nemo can be modeled by this log function. So we have this log function, and it helps us to find the revenue. Okay, it tells us the revenue from this movie Finding Nemo movie. Okay, where x is the number of weeks since the movie opened. Okay, our x represents the number of weeks since the movie opened, and r of x is the revenue. Okay, r of x is the revenue in millions of dollars. How many weeks? Okay, how many weeks means what are we looking here? What are we trying to find? X, because x is the number of weeks, so we are looking for x. Okay, our x is unknown, so this is what we are trying to find. How many weeks after the opening of the movie was the cumulative revenue equals to $300 million. Now what is this $300 million? It is the revenue, right, which is r of x. So let's substitute 300 for r of x. Okay, so you are not writing the millions. Okay, you are only writing 300 because our r of x is a millions of dollar. Okay, so it's already r of x is already defined as a millions of dollars. So you're gonna write 300 equals to 78.05 ln of x plus 1 plus 114.3. So your revenue, you substitute 300 for r of x and you solve this equation. This is our log equation. Okay, now we're going to use our concept here. Now what would be our first step here? So we are collecting log term in one side and the other on the other side. So we have this log expression on the right side. So let's get rid of 114.3 at first. So we subtract 114.3 at first, 114.3. So this is 0. So 300 minus 114.3, that's 185.7 equals to 78.05 ln of x plus 1. Now this log has 78.05. So let's get rid of this. So how do we get rid? Divide, right? Because we have a product here. So divide both sides by 78.05. So 185.7 divided by 78.05. 2.379. 2.379 equals to, this is 1 ln of x plus 1. Now we have a single log expression in one side, so we get rid of log now. And how do we get rid of log? We write in terms of exponential form. So you are writing whatever you have with log. So we have x plus 1 equals to base. What is the base? This is a natural, ln is the natural log, and natural log has a base e, and whatever you have on the other side. So this is what we have on the other side. This is the exponent. So e to the power 2.379. Okay, so we subtract 1 on both sides. So our x is e to the power 2.379 minus 1. Now you use your calculator and we get number something like 9.794. Okay, so almost after like a 10 week, they're gonna have a $300 million as a revenue. Okay, so this is our final answer. After like 10 week, they're gonna collect 300 as a revenue. Okay, any question? So let's do this much for today. Okay, remember